Hey everyone, this video is on dimensional analysis, and sometimes called the factor label method, and it's probably the most important technique for solving problems that you're going to encounter in all of your science classes. I want to review what you may have already done in the past and show you how we're going to do it this year and from now on. I'm going to take a really simple example to illustrate my point. Let's say you have 8 quarters, and I'm going to abbreviate quarters as, actually I'll write it out. I'll just go ahead and write that out, quarters. And I ask you, how many dollars do you have, right? 8 quarters equals how many dollars? Now, do you really need to sketch this problem out on your paper to solve it? No, right? You divide by 4 and you got 2 and $2, right? You could do that in your head. Well, what's the formal math involved in this? This is what your brain did without you even knowing it. It set up a conversion factor. If you have 8 quarters, what your brain did was set up the conversion factor. Well, for every $1, I have 4 quarters. So therefore, I divide 8 by 4. What this is here is a conversion factor. It's the equality. It's a way to relate two different units, in this case, dollars and quarters. $1 is equal to 4 quarters. So conversion factors are equalities. The reason why we divided was because quarters divided by quarters cancel. The units of quarters cancel when they're divided out, as do any units. 8, you don't have to do this, but you could write that whole number of 8 as a fraction over 1. What that illustrates is quarters divided by quarters easily cancels. Now, what do the numbers do? 8 times 1, right? 8 times the number 1 across the tops of these fractions is 8, and then you divide by 4. So 8 times 1 divided by 4 is 2, and we're left with the unit that doesn't cancel of dollars. I know that seems like a lot of work for something that you could have done in your head, and it's really obvious, but I guarantee you we're going to do much, much, much more difficult conversions later on, and ones which last 4, 5, 6, 7 steps that you can't do in your head. The way I like to do this, though, I'm going to use the same exact example, and I'm just going to abbreviate Q for quarters, is to use what's called a grid. A grid is a really useful technique, especially if you don't have the neatest of handwriting. You could use fractions like I did above, but it's simpler and much more straightforward if you're a messy person to write it as a grid. The grid represents the fractions. Whatever's across the grid, on top you multiply, and then whatever is on the bottom in a box, you divide. Again, this box is left empty, and that's just fine. Notice that with this diagonal rule of things that are diagonally divide out and cancel, notice, right, the quarters are diagonal and they cancel. One of the reasons why I like these grids is it makes it even more obvious that you have a diagonal relationship here. Quarters divided by quarters will cancel. And, we get 8 divided by 4 is $2. Let's take a different example. Let's say you had 3 octopi. How many legs do we have in this tank if we have a tank full of 3 octopi? Well, I know you could do it in your head. 8 times 3 is 24, Mr. Schaefer. Again, the formal math that you did was you set this up in your head. Your brain realized this, and you didn't even know that your brain was doing it. What your brain did was it said, there are 8 legs in every one octopus. And the reason you multiplied by 8 was because octopi divided by octopi cancel. We multiply what's across the top, 8 times 3, 24. We divide by what's on bottom, 1, which leaves us with 24. So we have 24 legs in our tank. Legs is the unit that does not cancel. Notice that the unit that is left over is the one that's in the upper right-hand box. We're going to do one more example. Let's say you're walking at a rate of 2 meters per second. You're moving kind of quickly. That's a very brisk walk. 2 meters per second, perhaps even a jog. And the question is, if you're walking at a rate of 2 meters per second, how far will you go? How many meters will you go in 15 seconds? When we set this up using the grid system, something that has a double unit, like meters per second, really could be written and should be written on a grid as per 1 second. This is a rate of 2 meters per 1 second. If you're driving 60 miles per hour, that means you go 60 miles per 1 hour. We typically don't show the 1. So if you're moving at a rate of 2 meters per second, you want to multiply by the number 15, because when we multiply by 15, we notice that the seconds cancel because they are diagonal. If we set up a diagonal relationship, the units cancel. 2 times 15 is equal to 30. Meters is the unit that is not canceled. So we can use dimensional analysis to put numbers together in ways that allow us to convert from one unit to another. The examples that we're going to be using later on are going to get much more complex, and I guarantee that setting things up in this grid system is going to clarify as well as simplify everything that we do. For now, that's it for this video.